Hey everybody, today's new lesson for today is greatest common factor, otherwise known as GCF, because that would be the G, C, and F in greatest common factor, GCF. And what we're going to be doing today is kind of a continuation of the prime factorization that we've done in the past. And what we're going to be doing now is we're going to be comparing two or more numbers at the same time. And actually not just comparing the numbers, so if I was comparing something like 12 and 28, all right, if I'm comparing those two things, basically what I want to do is I want to come up with the factors of 12 and 28, and I want to find what's common amongst the factors of those two things, of the 12 and 28. And there's two methods to do this, as I have shown here, listing the factors and prime factorization. And I'm not going to do the 12 and 28 yet, but I want to remind us that listing the factors and prime factorization are things that we've done. Okay, listing the factors. If I want to list the factors of 12, well, what we did, actually I want to rewrite that. If I want to list the factors of 12, the way we've done that is you start by saying, well, what numbers multiplied together give you 12? And we make a list. So we started with, well, 1 times 12 gives me 12. We use our divisibility rules. I know that 2 goes into 12, so 2 times 6 equals 12. And then we go on to 3. 3 times 4 equals 12. And we were able to come up with all of the factors of 12, 1, 2, 3, 4, 6, and 12. Okay, so that's one method that we're going to be utilizing today, is listing the factors. The second thing is prime factorization. And when we're doing prime factorization, what you should really be thinking of is the word factor trees. Okay, all of our favorite things to do here, factor trees. So if I'm going to take 12 here, basically I want to break this 12 down. I want to break it down into prime factors. So this is where we make our tree. And I say, okay, what can multiply together to give me 12? Well, how about 2 times 6? And I know that 2 is prime, so I can circle that. The 6 is not, so I got to keep factoring it down until it is prime. That's 2 times 3. 2 is prime, 3 is prime. And then when I would write that as 2 times 2 times 3, okay, just like that. Now for our final answer, if it was prime factorization, I would then switch this 2 times 2 to an exponent of 2 times 2 times 3. Okay, so there's the second method that we're going to be using today. If the question asks you to use prime factorization, we're going to be using factor trees. Okay? Example 1. Find the greatest common factor of 12 and 28 by listing the factors. So because they specifically asked me to list the factors, that's the method that they're going to ask me to do. So I'm going to start by writing these numbers down. 12 and 28. Okay? And now what I simply have to do is go ahead and list the factors of these things. So for 12, I want to list the factors. Well, we already did this. We have 1 and 12, because 1 times 12 is 12. We have 2 and 6, because 2 times 6 is 12. And we have 3 and 4, because 3 times 4 is 12. Now let's move on to the 28. Okay? Again, you always start with 1 in itself. So I've got 1 and 28. Then use your divisibility rule. Since I started with 1, now I'm going to try 2. I know 2 works because 28 is even. So 2 times 14 gives me 28. Okay. 3 doesn't go into 28. I know that by using mental math, but plus, because 2 plus 8 is 10. All right, 10 isn't divisible by 3, so my divisibility rule didn't check. 4. I know that 4 times 7 is 28. So I can write down 4 times 7. 5 doesn't go into there because it doesn't end in a 0 or 5. 6 doesn't go in there. And if I move on to 7, well, I already have 7 written down, so I can stop. So those are my two lists. Now, when we're talking about greatest common factor here, it's exactly what it sounds like. Greatest common factor. Well, here's all the factors listed. I want to find the greatest one that's common in both their lists, or the biggest number that's in both of their lists. Okay? So if I start looking at these, okay, there aren't a 12 in common or a 28. They don't have 14 in common or a 6. They don't have a 7 in common. The first number that's common between these are the 4s. 4 is the biggest number that's common, or the greatest common factor. So GCF equals 4 in this case. It's the biggest number that's common between the two of them. Okay, here's one for you guys to try. Find the greatest common factor of 24 and 36, again, by listing the factors. So I'll get you started. You're going to write down 24. You're going to write down 36. Give yourself some space to list these things. Now I want you to go ahead and pause the video, list the factors, find the GCF. Okay, should be back. Listing the factors. Factors of 24. You should have came up with, and I'm going to give myself a lot of space, because 24 is a common number here with a lot of things going into it. 1 and 24, I know it's even, so 2 works. 2 times 12 is 24. I know that 3 times 8 is 24. I know that 4 times 6 is 24. The only number in between 4 and 6 is 5, but 5 doesn't go into 24 because it doesn't end in a 0 or 5. So those are all my factors of 24. Let's move on to the 36. I always know it has 1 in itself. No matter what, always has 1 in itself. So 1 in 36. It's an even number, so 2 times something equals 36. And if you don't know what it is, you might have to do this off to the side. Since I know that 6 goes into here, I'm going to give myself a little more space. If I know that 2 goes into 36, I might have to do a little long division to find out how much. Well, 2, 1 left over, bring down the 6, 2 into 16, 8 times, gives me 16. Okay, nothing. So it goes 2 times 18 is what I came up with, equals 36. Okay? 3, well, I know that 3 plus 6 is 9, so 9 can be divided by 3, so I know that 3 works. Again, you might have to do a little long division and do 36 divided by 3 to figure that out. That's 1 time. Bring down the 6. 3 goes into there twice, so it goes into there exactly 12 times. So 3 times 12 works. Okay, I know that 4 times 9 works. Okay, 5 doesn't go into there. 6 times 6 works. All right, now we're looking for what's common between these. Okay, they don't have a 36 in common or the 24. They don't have the 18s. They do have the 12s in common. So greatest common factor, the largest number that they have in common is 12. Some people want to try to say, well, yeah, but they have more things in common. They have 4s in common. They have 3s in common, 2s in common, and they have 1. It's always going to have a 1 in common. But we're looking for what is the greatest one, and the greatest one is 12. So that's our answer. Okay, example 3. Find the GCF of 15, 75, and 20 by listing the factors. So again, we're going to start by writing these down. 15, 75, and 20. Now, if you think you know how to do it with 3 numbers, go ahead and pause the video, give it a try on your own. If you're not quite sure, then you can go ahead and listen, because I'll keep talking. Basically, when you're doing 3 numbers, it's the exact same thing as anything else. All right. We're going to start by listing all of their factors. So 15 is going to be 1 and 15. I know that 2 doesn't work because it isn't even. I know 3 works. That's 3 times 5. 4 doesn't work. That's all the numbers we have. Okay, 75. We have 1 and 75. Okay. I know that 3 is going to work because if I do my divisibility rule, 7 plus 5 is 12, and I can do 12 divided by 3. So I know that 3 is going to work. All right, and I always think of 75 as like money, so 75 cents. There are 3 quarters and 75 cents, so 3 times 25 is what gives me 75. 4 doesn't work. I know 5 works because it ends in a 5, and I might have to do a little division off to the side. Do 75 divided by 5 to figure out it goes in there. If I do my work here, exactly 15 times. Okay, so 5 times 15. 6 doesn't work because the 2 didn't work, and you need 2 and 3. 7 doesn't work. 8 doesn't work. Okay, we're done. The 20. We've got 1 and 20. I know it's even, so we've got 2 and 10. 3 doesn't work. I've got 4 and 5, and since 4 and 5 are numbers right next to each other, that's when I know we're done. Largest number that's in common, greatest common factor. Okay? Well, they don't have a 75 in common. Sometimes it's easier just to start with the largest number like 75 and just use that and work our way down. They don't have a 25 in common. They have a 15 in common here, but there isn't one in the third one. Okay, so the 15s don't work because here's the trick. For 3 numbers, it has to be common, and all 3 of them, like the 5s are here, is common in all of them. That is the largest factor that's in all 3 of them. So it's the biggest number that all 3 of them can be divided by. So there's greatest common factor. Okay, new type of a problem. Find the greatest common factor of 120 and 75 by prime factorization. So now, prime factorization, they're telling us to use a different method. They're saying use factor trees. Okay, so if they give me 120 and they give me 75, I'm going to list those, and now we have to break those down using factor trees. Okay, so you can break it down how you want. You might not sure you work the exact same way as me as far as what numbers you're using, but when I break down 120, I have some options. I can do 3 times 40, I can do 2 times 60 if I want, I could do 10 times 12. You can choose what you want, but we should end up with the same answer. I know that 2 is a prime number. I can break down 60 into 2 times 30. The 30 can become 2 times 15. 2 is prime. The 15 can become 3 times 5. And those are both prime. So now I'm going to write it. I'm going to write these over in the middle here. Okay? So I'm going to write, since there's I'm going to change colors, a 2, a 2, and a 2. Well, that gives me 2 times 2 times 2 times 3 times 5. Now, notice I did not write 2 to the third power. I did not write this as 2 to the third power. If they ask for prime factorization as an answer, that's how I would write it, is 2 to the third power times 3 times 5. But that's not the question. Because they're asking us for greatest common factor, this thing right here is not our answer. It's just a tool that helps us get our answer. Okay? When I break down the 75 now, okay, and maybe I'll move it over here a little bit, 75. Okay, again, I think about it as money. So 3/4, so 3 times 25 is 75. The 3 is prime. The 25 becomes 5 times 5. They're both prime. So I get 3 times 5 times 5. Actually, I'm going to change that to blue so you can see what we're doing here. So, and I like to stack these two things on top of each other. Okay, I take the 120 and I put it in one place. I take the 75, I put it in the other. And the reason I do that is because it's just easier to compare, because now I want to say what's common in both of these. And what I see is, well, they have a 3 in common. Okay, they also have 1 5 in common. Now I know there's a second 5 here, but because there isn't a second 5 in the top, I don't care about that. And what we're going to write down here is what's common. I have a 3 in common, I have a 5 in common. So this is what's common. There was a 3 in common, there was a 5 in common, and finally GCF then is 3 times 5, which is 15. Okay? Here's one for you to try. Find the GCF of 90 and 150 by using prime factorization. So go ahead. Again, it says prime factorization, so that says use factor trees. This one's for you guys to try. So pause the video and go to it. Okay, you're back. When we break down 90, the first thing I think about is 3 times 30. Okay, the 3 is prime, so I circle it. The 30 becomes 3 times 10. The 10 becomes 2 times 5. Okay, now I'm going to write this least to greatest. So I have a 2. Actually, I'll change colors here so we can tell the difference. I have a 2, which was this one. I have a 3 and a 3. And then finally a 5. So there's my 90. Okay, now I've got to do the 150. So if I break down 150, I think of, let's do 5 times 30. Okay, and there could be lots of things. I could have done 15 times 10. I could have done 2 times 75. There's lots of things. I chose 5 and 30. Break down the 30. How about 3 times 10? 3 is prime. The 10 becomes 2 times 5. And again, we're going to write down least to greatest what we have here. So I have a 2. I have a 3. Everything that's circled. And I have 2 5s. So times 5 times 5. And then to find the GCF, remember we're going to circle what's common, and we're going to keep what's common. So I have some 2's in common. So I write that down. I have some 3's in common. So I write that down. I have some 5's in common. Okay. And then, since the only numbers that are left are 3 and 5, they're not common. So I do 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30 for our final answer. GCF is 30. Last problem of the day here. Find the GCF of 28 and 45 by prime factorization. Okay, I want you guys to listen to this one. I don't want you to do it on your own. This one's a little different. That's why I added it on here. I want to show you what happens here. If I try to use prime factorization, which is factor trees, and I break this down, for 28 I get 4 times 7. The 4 becomes 2 times 2, which are prime. The 7's already prime, so I get 2 times 2 times 7. Okay. For the 45, if I break that down, what comes to my mind is 5 times 9. 5 is prime. The 9 becomes 3 times 3, which are prime. So I get 3 times 3 times 5. And if you look at these two things, comparing, and we want to find what's common between these things here, there isn't anything that's common, because even though I have some 2's on the top here, see I have some 2's, there aren't any 2's on the bottom. There's a 7 on top, but there aren't 7 on top. I have 3's on the bottom, but no, there's nothing common. Nothing common. But our answer isn't 0, and it isn't that nothing's common. When we do this, if you notice, and this is just a little trick, if you notice that there's nothing in common, every single time the greatest common factor is going to be 1. It's going to be 1 every single time. And think about that. The reason is think about what a prime number is. 28 and 45. Every number has 1 and itself as factors. If we were to list these, you'd be able to see it, because you'd start by going 1 and 28, then you'd have things in the middle. Then you'd start by going 1 and 45, and again you'd have things in the middle. Eventually you would see that there are 1's in common. Unfortunately, when you do prime factorization, you don't get to see anything in common. Greatest common factor is 1 automatically, and that's just something we're going to have to know. It's 1. If that's the case, if the answer is 1, I'm going to throw one more term at you. This is what we call relatively prime. Something is relatively prime if and only if the greatest common factor is 1. So 28 and 45 are numbers that we call are relatively prime to each other. Okay, that's the lesson for today.